Sampling and confidence intervals in Python. Welcome! Today we will learn how to use sampling and confidence intervals in Python. These are ways to make sense of lots of numbers and to guess things about big groups even if we only look at a few members. By the end, you will be able to do real-world data sampling and estimate ranges for answers. Running the cell now. Start by thinking about how we can never measure everything, but we can make good guesses with a few smart samples. Make sure your Python is installed and ready for data work. Let us see the version now. This comment describes what we are doing. Comments start with a hash symbol. Here we import a built-in tool called System to check our Python version. Let us print our current Python version. Running the cell now. If you can see the version printed, you are ready. Try typing your own print statement to practice. What is sampling? Sampling is when we pick a few items from a big group to study. We do this because it is often too hard or expensive to check every member in a large group. For example, testing a few pieces of candy from a bag to guess if they all taste good. Running the cell now. Pause and think, can you name a time you sampled instead of looking at everything? Type it out now if you like. We will make our own group of numbers to practice sampling. Think of this as a big crowd with 100 people. We make a comment for humans reading our code. We build a list called population. It contains numbers from 1 to 100. Running the cell now. Try changing the range to make a smaller or bigger population. See what happens. It helps to peek at our data. Let us view the first 10 items in the population list. This comment explains that we are showing a part of the group. We print just the first 10 numbers so we see how the list looks. Running the cell now. Practice, change 10 to another number and see a different part of the population. Taking a simple random sample. We can use random sampling to pick a few members from our big group. This way, every person has a fair chance of being chosen. Python's random module helps us with this. Running the cell now. Notice how random sampling helps keep our guesses fair, no favorites. Now let us pick our sample. We will choose 10 random people from our population. We import the random module for picking random items. This comment explains that we are making a random pick. We use random.sample to select 10 unique numbers from the population. Now we print the people our sample includes. Running the cell now. Try pressing play again. Notice how the sample changes each time. You can change how many you sample, try different numbers. Let us compare the full population to our smaller sample. We will find the average, also called the mean, for both. This comment tells us we are finding the mean or average. We import statistics, a module for math about data. We use the statistics.mean function to get the population's average value. We do the same for our sample. Let us print the mean for the whole population. Then we print the mean for just our small sample. Running the cell now. Practice, run this cell several times. See how the sample average changes. Can your sample sometimes be very different? What are confidence intervals? A confidence interval is a range. It tells us where we think the true answer is, given our sample. We are never 100% sure, but we can provide a good guess with a level of confidence, like 95%. Running the cell now. Think, if your sample mean is 20, where might the true mean be? Let us find out next. Confidence intervals need to know how much our sample bounces around. This is called the standard error of the mean. A comment to say what we are calculating. We import math for the square root function. We find the sample's standard deviation. It tells us how spread out values are. We count how many in our sample. We calculate standard error by dividing the sample spread by the square root of sample size. Let us print the standard error. Running the cell now. Remember, a small standard error means our guesses are more trustworthy, while a big one means there is more uncertainty. Let us make our confidence interval. We will use 95% confidence, which is a common choice. The comment explains our goal. We set the confidence level to 95%. We use a z-score of 1.96 for our level of confidence. To get the lower end, we subtract z times the standard error from the mean. To get the upper end, we add z times the standard error to the mean. Now we print the range where we think the true mean falls 95% of the time. Running the cell now. Try adjusting the z-score to a different value to see a wider or narrower range. It is good to check if our interval caught the real mean. Let us find out. This comment sets our question. We check if the real mean is between the lower and upper boundaries. Now we print if the real mean is actually inside. Running the cell now. Try running this cell several times. This time, you may see true or false since random sampling means sometimes we miss the true mean. How do larger samples help? When we take larger samples, our estimates usually get better. The confidence interval gets smaller, meaning we are more certain. Running the cell now. Let us try this idea out ourselves. Let us pick 50 random people from our population. Watch how the confidence interval shrinks. This comment reminds us of our goal. We grab 50 instead of 10 numbers from our group. We get the new sample's mean. We measure the spread within this big sample. We figure out the new standard error. Lower end is new mean minus z times new standard error. Upper end is new mean plus z times new standard error. Print the mean for the bigger sample. Print the new, often smaller, confidence interval. Running the cell now. Notice the range is now tighter around the real answer. More data gives better estimates. Now you get to make your own choices. Choose how many to sample and see what happens. This comment explains what we will do. We ask the user to enter a number for the sample size. Then we turn their input into an integer. We pick that many random items from the population. We calculate the mean of your sample. We find the spread for your group. We compute the standard error. We get the lower confidence bound. We get the upper confidence bound. We print your sample's mean. We print the confidence interval for your group. Running the cell now. Try different numbers for the sample size. How small can you go before the interval gets too wide? If you are learning something new, like the video, leave a comment and subscribe for more fun Python lessons. Let us see what happens when we repeat our random sampling 100 times. We will count how often our confidence interval really captures the true answer. The comment tells us our goal. We will do 100 tries. Start a counter for how many times our interval is correct. Run a loop for each attempt. Sample 10 people again and again. Find the mean for this try. Find the spread. Standard error for this sample. Calculate the lower end. Calculate the upper end. If the true mean is included, add 1 to our count. Print how many times the interval included the real mean out of 100 tries. Running the cell now. Did you notice the success rate is close to 95 times out of 100? This is why we call it a 95% confidence interval. Try repeating with a different sample size or more trials. Mini project, candy quality sampling. Imagine you work at a candy factory. You want to know the average weight of candies in a batch, but you cannot weigh every single one. Let us use Python to estimate the true average with a sample and report our confidence about it. Running the cell now. You can imagine tastes or weights or colors in your factory. Ready to code our project? Let us make a pretend list of 500 candies with weights that are about 10 grams. We mix in a little randomness to be more realistic. A comment for humans. We set a random seed to make sure we can repeat our results, so you see the same numbers every time. We use a special random method that gives values with a mean of 10 and a spread of 0.5 for 500 candies. We preview the first 10 candy weights. Running the cell now. This looks like data from a real lab. Imagine each number is a candy's measured weight. Let us pick 25 candies to weigh. We will estimate the batch's average and our confidence in that guess. A comment outlines the plan. Set our sample size to 25. Pick 25 candies at random. Calculate their average weight. Get the spread in their weights. Calculate the standard error. Estimate the bottom of our weight interval. Estimate the top. Print out our best guess at the average candy weight. Report our confidence interval. Running the cell now. What do you notice? Change the sample size and see how your interval grows or shrinks. Now it is your turn to run the candy factory. How many candies will you sample for your quality check? This comment shows our next step. We let the user choose how many candies to check. Their answer becomes a number. Pick that many random candies from the batch. Get the average for your sample. Find the spread in your group. Calculate standard error again. Compute the lower end of the interval. Compute the upper end. Report your best quality guess. Show your confidence interval from this batch. Running the cell now. Try some small and some large sample sizes. Which feels more trustworthy? If you found this helpful, press like, share, or comment below with the sample size you tried. Recap. Key takeaways. Sampling helps us guess about big groups without checking everyone. Confidence intervals show how certain we are about our guess. Bigger samples give us tighter, more trustworthy intervals. These ideas are used in science, medicine, business, and more. Running the cell now. Practice time. Think of another thing you might sample in real life and try writing your own Python code on it. Thank you for learning with us. If you enjoyed this, please like the video, subscribe, and share it with friends. Let us know your questions or how you might use sampling in your own projects. See you in the next lesson. Running the cell now. Take a moment to review and reread any part you found tricky. Come back soon for more Python.